Fabio Zambrino from CSCS. Please welcome.
Okay. So, hello. I'm Fabio Zambrino. I'm leading the IT information security team at CSCS. And today I'll try to make this presentation in the context of AI. First of all, I would like to thank the organization for giving me this opportunity, and also my colleague Victor Holanda, who's here around, that helped me with the slides and with the whole presentation. So I'm not an AI expert, but I'm trying to apply my cybersecurity knowledge to the new challenges that AI is presenting now. And there are three things that are important for me to discuss today. That are, one is about the new challenges that we as security professionals are seeing rising with the usage of AI in HPC centers. From the cybersecurity perspective, we see the AI tooling as another software to be protected, or to protect from also. And then I would like to highlight that the work that we need to do is to tackle the cybersecurity problems that could rise here, need to be done together from AI experts and cybersecurity specialists, because we as cybersecurity specialists have a limited view of the whole landscape. But I would like to start from the perspective of data to discuss the topic, because in traditional HPC applications, so we have mathematical modeling, real-life experiments, or data that are taken directly from, in this case, a telescope. And all these data are used for calculations. And what's in common here is the fact that we are supporting this, all this science and giving the infrastructure for the real calculation. And the data in this case are stored in science portals that are trusted sources, or trusted portals where users can send data or get data to then make some calculation on our center and create new data that then are re-uploaded on the scientific portals. And here, let's say everything is trusted, because the applications are there, and you usually trust that the data that are published on those science portals are data that you can use safely. Those data are available to other scientists also, not only to scientists that are calculating in a specific center, but they are doing science in a community. So they usually also use other centers for the calculations, and they are using multiple portals because they are applying on different sciences. So there are multiple portals for every science, and the landscape is already quite complex. What do we care in this scenario from the security perspective is that the bad guys should stay away from our infrastructure. We should protect the infrastructure, and we have threats almost everywhere. We could be having threats from people attacking the science portal, so the source of data, or directly the instruments from where the data came from. Bad guys trying to hack into the system to then get access to other centers, or misuse the HPC infrastructure for any kind of application, or attack, as I said, attack other centers. With AI, the landscape changes a bit. With AI, we need data from internet, so the data are living, and we need to train models and get data from internet, because we always need fresh data to train the application. And the usage of internet, you all know, will expand the scope and the threats that can be running on the machines. And the data that you can download now are related to science data, but also kitten or landscape pictures that needs to be used to train the models. And as I said, the landscape, so the threads from internet are a lot, and it will expand how you will see the whole threats, so how we see as security professional the threat landscape for the centers. We need to find a balance to align to the new workflows, and this has a lot of challenges. From the whole landscape, I will just be focusing on the aspects of the data living on the internet, and I will start with the new challenges that we see from these new AI workflows. We have an increase in the challenges because what's happening is that there is an increased number of users accessing the HPC infrastructure, and the applicability of HPC is increasing because it will help, or it will be involved in many social aspects. And then we have HPC machines that are needed to, as explained already this morning by Thorsten, we need computational power, and this computational power comes also from HPC machines. What do we see at the moment is that there is an increased phishing. There are increased phishing campaigns, so phishing campaign targeting specifically HPC users or people working in the HPC centers. And the phishing campaigns now are also more precise and accurate, thanks also to AI. Related to that, there are social engineering attacks increasing, and also new type of malware and campaigns targeting also, and more specifically university and HPC users. This is an example of bad guys trying to attack the HPC infrastructure, but we have also articles mentioning the hackers targeting the University of Zurich with a so-called professional cyber attack, so not a script kiddie, but an organization trying to get information or usage of the University of Zurich information or user data. And also there is an increase in the malware campaigns. Autocolor was, end of last year, was talked a lot. This is a new malware campaign to get access of Linux machines, full remote access to Linux machines. So we know that HPC machines are mainly using Linux. Another type of threat that we see is the weaponization of our infrastructure, and we can become threats for others, or mainly internet now, but also other centers. And data are valuable to AI, and we need to have a lot of data in our center, but also we need to download a lot of data from internet. And the data used from AI are spread around the internet and not on specific portals like I said before. What we see is that unintentionally it happens that users are crawling internet and creating DDoS because they just download from GitHub some projects and they start running it, but then it's not running on my laptop from my home network using a 100 megabit connection or 1 gigabit connection. It's using much powerful machines and an internet connection that can cause denial of services to service providers. And in this case, as a consequence, we are marked as the bad guys. So we end up in gray lists or block lists, and coming out from this list, it's quite difficult, and it has also a reputational impact. The security impact of AI workflows is not yet fully assessed because it's too fresh. So security is quite slow, and AI introduction was too fast for security measures. And hackers are not stupid, and they see that the trend is AI, and they're trying to leveraging it. And knowing also that AI needs a lot of computational power, they will be targeting AI to have access to the resources. So this is an example of us becoming the bad guys for internet, but most importantly is that one of the most important things is that tools to protect to this kind of threats are still in development, so they're not present yet. We're running still a bit late. And an example published by JFrog is that what we see nowadays is that hackers are able to inject malicious code in compressed libraries and being able to run their workloads embedded in machine learning models. And there are also other articles I will mention later that highlight this. As I said before, AI is just another software stack, but it's a completely different software stack from what we have seen up until now in the HPC systems. And they are interconnected. So we need internet or data exchange to be efficient with the AI models. And they are quite susceptible to hackers. And what do we see is that hackers are exploiting collaborative AI platforms, and this is the problem that I just explained before. There is an increase in AI-related library exploits, so mostly in Python we see that hundreds of libraries related to AI are injected with bad code than I see. And there is a broader set of application security issues that can lead to more supply chain attacks. And last but not least, we have seen also the use of not safe for work data. That not safe for work data is just kind of content that you don't want to, usually you don't want others to see that you are looking at, okay? There are articles mentioning the fact that Hugging Face was containing 100 malicious code execution models, and also that some Python libraries were delivering also cryptocurrency miners because of they became vectors for supply chain attacks. What are we doing so far? So at CSCS we have implemented MFA. This is great because we have seen an impressive decrease in user compromission, but we know that we can do a bit better because CISA is strongly suggesting to adopt FIDO2 because FIDO2 is phishing resistant. We adopted a firewall. We have a firewall to generally protect the network, but also in this case we can improve a bit. We would need to extend the reach and the bandwidth because we need a bigger amount of data. We have a bigger amount of data exchange, and not only related to AI. We have implemented a SIEM, but we need to extend the visibility because of the new use cases. We have implemented already some, but we need to improve it. And then we are monitoring the network, but again, we need to apply some intelligence because the data load is increasing, and we should be able to apply some intelligence to find something useful out of all this data. Then we applied some security to Kubernetes, having some security assessment. We should extend the security assessment, and also we should extend the visibility that we currently have on the container workflows. What are we still missing? Because we are still missing, I think, a lot of things to be applied on the AI. We should, given all these increased threat landscape, we should try to protect AI software with static, dynamic, and interactive advanced interactive application testing, so security application testing. And also we should find a way to do some malware analysis on the AI data, but not only on the data, but also on the models themselves. This is something I read recently. We should think about introducing the data privacy into AI. There is the differential privacy that can be applied. Again, I'm not an expert here in differential privacy. Maybe other colleagues knows better, but I read something about PyTorch or Opacus that can be applied and used. And then we should improve on the policies that applies to AI workflows because, for example, the not safe for work data that are used at the moment. At CSCS, we are, this is a portion of the security solution that we have at CSCS. So Ivano was showing us before how we can partition Alps into vClusters. We tried to tackle it from the same perspective, so we applied some security measures and agents on the vCluster side. We started installing the Wazoo agent, doing some reframe tests and tenable scans of the vClusters. But we have an additional security issue with some vClusters because some vCluster can connect to internet. We have a high-speed network also for internet, and those vClusters that can connect to internet should connect to internet through a proxy and the firewall. And to monitor the traffic there, we have NTOPNG and Maltrail that can see if there are connections to known malicious website or possible threats inside the traffic flows. So the tools that I just mentioned are helping us and giving us some tools that we can give to the management also, so we can generate reports for the management to give them a big picture of what's the security posture of the center. We can verify the hardened system configuration, and we can monitor the network traffic. Here is an example of one of the reports we send to the management. This is a confidential report that we send to them with the vulnerability trend inside the center. This is what the service manager are getting before going to production. With the reframe test, we are doing the security scanning that we call system health check. And also on the network side, we can look at how the traffic is going with NTOPNG or Maltrail or the firewall itself, so that we can identify if there are malicious execution running on the cluster. An example of real threat that we have seen, and unfortunately we became the bad guys, is that one of the users unintentionally crawled the internet from our cluster, and we got a notification. So we noticed something bad happening on the network, but at the same time we noticed it. We received an abuse report from one of the ISPs telling us that we were put in gray list because this user was, so this is what we have seen on our network, but the fact was that this user was just crawling the web to download images. It just took a random list of 400 million of images to be downloaded, and he just ran it with some containers on the cluster. And of course, the provider was just telling us, don't do it because it will just block our service. So you should avoid doing that. And the abuse report was just telling that at the moment we were put in the gray list. If we continued, we would have put in blacklist. The blacklist then spread, and if the blacklist spread, all the providers will put CSCS IP addresses in the blacklist, and then it would be difficult for us to communicate with internet. Okay, so until now I talk about what we are doing from the perspective of security teams in HPC Center, specifically at CSCS, but there are many things that we cannot do, or at least we cannot do alone. This is something more related to AI specifically, and how AI is currently implemented and used. So the weaponization of AI is a thing, because in cyber we say that real hackers don't break in, they log in. And in AI, in the AI world, we can change it a bit and say that real hackers don't compute, but they prompt engineer, because this is what's now a trend. They try to prompt engineer to use the current AI to find out bad usage of the AI. Last year, in the second half of 2024, there was a high increase in phishing, so voice phishing operations, because AI is helping a lot in this kind of time-consuming activities for hackers, and they are targeting quite well. So they're able to create realistic voice traps to get information out of any different field they want. And there was the 79% of security breaches detected were malware-free, meaning that hackers don't need to send you a malware to get into the system, but nowadays they can also use simply social engineering stuff for attacking your system. And then that 52% of vulnerabilities were related just to the initial access, so the surface of attack, not the specific computational resources or deeper resources that you can have in your company. Then there is the extreme case of WormGPT. It's a generative AI tool used for cybercrime, so a model trained to suggest bad things to do, and this is also another side of the coin that we should at least tackle somehow and try to limit as much as possible. The other problem is that there is the need to acquire the data, and as I said, the data are living on the internet. We need fresh data for the AI training, but this is marked now as a bad behavior. So we are more and more marked as bad guys just because we are crawling internet, downloading data, and we should think about a solution to limit this kind of behavior. Then there is another threat. It's a social threat that there are people that simply don't like AI, so they will block the adoption of AI. And also, a bit more aggressively, there are people dedicated to poison AI models, and here I have two examples of these behaviors. To conclude, I think that the most important thing that I would like to express here, and that we should not forget about, is that AI is still, fortunately, a human activity. And no matter what, if we are protecting against AI threats or pushing AI to their limits and breaking the limits, we should never forget that AI is still something that we can and we must do as human. And we can choose what to do with it. I think we should do it responsibly, because as I've written here, we can choose what, how, when, and what to do with AI. We should be responsible. We should be prepared also to bad adoption or utilization of AI, and we need also to protect our system, but also the research related to AI, because we don't want that the research will go in a wrong direction. With that, I thank you very much, and I'm open for questions.
Any questions?